Okay, let me explain what I'm doing. So, I bought this clock, and I've already done some work to it, and I'll show that here soon. I bought this clock at an estate sale. It was like $5 or something. It was something I've been looking for. I want a flip clock because I find them to be cool and non-existent. And it came with a radio, which is actually what I wanted. I wanted a clock radio. This one is by Soundesign. It is model 3464. And, you know, my initial plans were to, you know, I thought it worked at first because the radio was acting strange. So I thought the clock was working because, you know, it was slow, and I didn't test it for over a minute, which I probably should have, but it doesn't matter because I got it for $5. The radio I thought worked, but what happens is when you plug it in, the radio works for like 2 seconds, 3 seconds, sounds all normal, and then it goes straight to heavy static. I wasn't sure what the cause of that was, and I'm not an electrical engineer, so I don't really know what I'm doing when it comes to working on old electronics. This is a radio I took out. I guess that's your tuning coil. I'm not really sure the parts of it, but this is what I took out, with a few other things. And let's go ahead and open it so I can show you what I did. Just pop off the dials and various knobs. And I want to return this to functioning order. The problem is this is part of your motor. The other part was extremely hard to get off, and I think was damaged, or not damaged, destroyed in the process. This was also pretty badly damaged. But the problem is this is the, I guess the, I don't know what you'd want to call it, the status reader. So when it spins, the lines progress across, letting you know that the clock is running, and that showed in this hole. And as it would spin, the line would progress across. But the problem is that would spin, and that's great, because the motor still worked. The problem is that the gearbox was completely stripped, so some of the gears were even cracked. So that's one of the gears. This is the gearbox that I cracked apart. It wasn't serviceable, because if it was serviceable, I wouldn't be doing this. The problem is all of the gears, like you could see all the little pieces of gears and whatnot, they're all stripped and cracked and not helpful when you're trying to use them for a gear. So what I did is I took the main pinion, or the, I don't think it's pinion, the main gear, that interacted in that hole right there, and I took that and put it on a stepper motor with a 3D printed gear, built this bracket so that it would screw in, and the motor mounts through those holes. I'm going to print some bushings or blocks that would go over these shafts here, and then you got the little nuts. Let's see, these little nuts go on the ends there. So I'm going to put a little sleeve over it, and that should lock this in. There's a screw over here I tried to utilize, but I think it's going to be too short. And my goal is to keep most of this as simple as possible, but by just changing out this, because I think my plan is, this is your radio. It's flipped upside down right now. But my plan is to strip out all of the electronics and keep the radio face at your front cover. And this is what I redid. So this is a stepper motor. I needed to do some modifications to this radio panel, which may be good, may be bad, but I did them, so we're going to see how they work out. But what I did was I 3D printed a gear, 3D printed 2 gears actually, and those gears go back to the original drive gear for the clock, because what happened was the gears, there was a gearbox inside. This was the I don't know what you'd call it, the status maybe. It spins as the motor spins, and it progresses across, letting you know that it's on. But the gearbox for it was broken, and I couldn't service it because it was a non-serviceable part. I guess at that point you just replace it. But I couldn't, so I decided to just go straight stepper motor. because I can replace that if that ever breaks, which I don't think it will because they're used in 3D printers all the time. It's a lower voltage, which I'm not a big fan of high voltage, which is not really high voltage, it's 120, but nothing I'm comfortable working with. And I just 3D printed the parts necessary. So let's see if I can hold it right when I turn it. It's 1 rotation equals 12 minutes. I'm not sure why it came out that way, maybe not the gear. But it's 60 teeth on this gear on the inside, and every click is 1 minute, so I'm not sure why it went from 1 to 12, because it's still rotating at the same speed, but I'm not really sure. But I do know that it's 1 every 12. 1 rotation is 12 minutes, so let's put it to a point where I know is marked. Okay, so it's 8:04. It should go to 8:16 for 1 full rotation. Yep, 1 full rotation, so it's 12 minutes. Okay, so for this project, as you saw before, I have installed the stepper motor, so now I need to get the electronics going. For this, I'm going to be using an Arduino Uno R4 with Wi-Fi. I chose not to use the Nema because for one of the functions of the clock, I need to get the time, and I'm not using an RTC module, so just with a little bit of extra code, I can get the time from an NTP server, which will be very helpful in placing my time for my lamp to go on and off. And I'm using an L298N stepper driver. These are very straightforward and simple. For these specific motors that I'm using, they are 5 volt, so I don't need to hook the 12 volts to 12 volts. I just need to hook it to 5 volts from the Arduino. That is to prevent overheating the motor, also overheating the driver. So let's get these in the clock, and let's see how it works. Okay, I'm now uploading the new code. You can see this light is now pulsing. I don't know if you can see it. The light's a little bright. Put the light on the Arduino. Now I'm printing to my serial, which was probably the most helpful thing with this project, was printing to the serial for the NTP, because I was struggling to get the time, so I had to force update it, which is something I've not done before. So now it's printing from the serial, so I can see over here on my laptop that it is in fact running the exact time. But this should step once every 59.875 seconds because it takes a little bit of time to step. So I ran a test. I ran it over an hour or 2 hours, and I realized it was off by 15 seconds, which was with the full 60-second delay. So it fell behind. So now it is on time at the 59.875 seconds. So you should see it flip again here soon. There it goes. See? So that was, because that was the second step it did. As soon as I turn it on, about 15-25 seconds later, it will step 16 steps. That was a 16-step step. And now on the next minute, which would be 8:20, will be 18 steps. So you can see down here, I don't know how well you can see, but there's this little metal tab right here, and that is what keeps the numbers where they should be until it passes up and turns. But what happens is that you can use that as a little bit of a guide to see where it is in its step. Now it's not doing it consistently. It's not currently consistently changing its position. It just does it at the end of every minute. But in between, you can see where it is in its step. So it's relatively close to the end. It's probably about 2/3 of the way down. And here it's a little bit further down, that was for a 16th step. Okay, it should be flipping again here. just a second. Should flip now. There we go. And now that was the 18th step, so it is a little bit closer to the end. So that is this clock. It seems to function fairly well. Obviously, the original was very, very good as it was, because it had a well-refined mechanism for changing the time. This won't be totally 100% accurate because there is a little bit of play in the gears. Not much, very, very little, because it's consistently driving, so there shouldn't be any backlash. And the clock is consistently running. And over, say, 17 hours that I ran it for the last test, it lost a few seconds, which is very good. And when I set it, I have to now step it a little bit. So that was this test. It was this test specifically. There it goes again. That should have been the 16th step. This was definitely an interesting project. I did enjoy retrofitting an older clock. It gave this clock a new life because it was on the verge of being in a landfill, and now it's not. It's got a new life. It's in my room, and yeah, it's a good little clock, and may modern technology keep it running. So the clock is all back together now. Like I said, I'm going to be doing the special fun features like the radio, which was not special originally, but I just got a running clock, which is really all I needed it for. So at a later date, I'm going to fix the radio and maybe add the special features. But right now I have some other projects I do want to work on. So I'll keep you posted on those. But this project, I'm going to call it done for now. If you do want to look at the code for this project, it's in my GitHub repository for Flip Clock. There will be a link down in the description for my GitHub page about it. It's just a simple little website about this project. And then you can go find my repository off of there. And it should have the code for this project. I broke it up into 3 parts. I have code for the clock. I have code for the lights and time. And I have a combination of the 2. So this clock is done. Check the code out. Check out my website. Thanks for watching. It's pretty good.